Hey guys, and welcome back to another A-level maths tuition video. So today we're going to be covering exponentials and logarithms. Been a long time coming. So with exponentials you should hopefully be aware of power laws, right? So indices and things like that. So the graph, for those of you that are interested, for all power laws is exactly like this. This is y equals a to the x, and it always crosses at 1 because any number to the power of 0 gives you 1. An exponential is just where a is equal to e, which is equal to 2.7 ... Okay, that's the only difference. And the reason for this number is that it turns out in a lot of kind of calculations that we do, especially in things like physics and economics, it turns out that the base tends to be a number which is 2.714 and so on. Now, manipulating this should be relatively easy, right? So if you remember your rules of indices, which I hope you do, so for example you have a to the power of m times a to the power of n, you just add the powers and so on. I'm not going to go through these today, but we will go through the opposite. So, one thing that you might not know is that there is actually an inverse operation which isn't just taking the square root, and it's called a logarithm. So a logarithm, all it is let's say you have log to the base 10 of 1,000. What this will tell you is how many times do you times 10 by itself to get 1,000, and the answer will be 3, right? 10 times 10 times 10. And if you look on your calculator, here's where the button is, it's just over here, and you'd fill that in, so 10 and 1,000, right? You get 3. You can also say, for example, have a different base. So you can have log to the base 2 of 8. So how many times do I times 2 by itself to get 8? Well, that should also be 3. Okay, so again, we'll just go through and we'll change these. Not 3, 8 even. And you get 3. Okay, so this might not seem too useful at the moment, because surely you could just kind of take a square root or something like that. However, we should keep in mind that we don't always have numbers that are super easy. So for example, what would the log of base 2 for the number 9 be? Right? This is where things can get a bit more interesting. And then of course we have algebra. So logarithms have all of their own rules associated with them, and here are some of them. So before we get started, actually, what I will say is that generally speaking, if we have log to the base 10, we don't bother writing the 10. So if you ever see log 100, that is the same as writing log to the base 10 of 100. When we work with exponentials, you're going to be tempted to have log to the base e of e squared or whatever. That is the same as writing ln of e squared. Okay, so that's just so you know for now. And again, the most important aspect of this is going to be things such as rearranging algebraic expressions. It's going to come up in integration and differentiation, and if any of you do kind of physics or economics, you have logarithmic graphs as well that you'll need to do. So it is quite an important aspect of maths, even if it doesn't seem too useful at the moment. So let's look at the rules. Now the rules here are not too bad. So log to the base b, so again, b is just going to stand for base, and it has to be the same, of the letter, let's choose x, plus log to the base b, so again, same base, y, is the same as doing log to the base b of x times y. Okay? So if you add logarithms together, you can multiply them. Now keep in mind that in your specification, you have to use these rules both ways. Okay? So sometimes you may have log of, let's say, 8, and you may be expected to do log of 2 plus log of 4 instead, and vice versa. So you might be able to guess that if you have log b of y minus log b of x, then you're actually going to be dividing them. And again, you need to be able to do this both ways. The next kind of things that we need to do is the power law, which just states that if you have log to the base b of x to the power of y, that is the same as just moving the y to the front and having log be x. This is one of the most important rules that we're going to come across. It comes up a fair amount. Now, another thing to note is that the logarithm function is the inverse function of power. So it's going to be an inverse graph. So if you were to draw it on here, it's going to be like this, where it should be a mirror reflection. So this is y equals log x. And this value here is always going to be 1. So what that means is that log of 1, and it doesn't matter what base you have, always equals 0. Okay? And that's for the same reason as this. Anything to the power of 0 gives you 1. So vice versa, anything to the log of 1 is always going to give you 0. And likewise, if you have log of a base, that should give you 1. And this should hopefully make sense, right? Like if I give you an example, if I say log of 2 of 2, I'm asking how many times do I times 2 by itself to give 2? Well, just once. And that's going to be true for any pair of numbers, right? So that should hopefully be okay. The last one, actually a couple more that we're going to do. B of b to the power of k. So if I take the log to the base of a power, then I just get rid of the power. So this is going to be really important when we come to rearranging equations. Okay, so what you'll find is you may have, let's say, 3 to the power of x. Then what you can do is apply log to the base 3 of this whole thing and just get x. And you do that to both sides. And that can make things a lot easier for you. Okay. And lastly, in a similar vein, if you have base b log base b of k, it gets rid of it. So you can always do the inverse. So if I apply log, I get rid of a power. If I apply a power, I can get rid of a log. Okay, so this is pretty damn complicated. This might seem like a lot of stuff, but as we go through it, it's going to be nice and easy and will make sense. Okay. The other thing to note is that these numbers must be positive. Okay, so in all of these cases, the number inside must be positive. You can't take log of a negative number. So let's get down to doing some of these questions. So let's start with this. Something that should be relatively easy. And we have 3x, well, 3 to the power of x equals 13, and we have to find the answer. So, using what we had before, if you remember, we can apply log to the base of that power. So if we ever want to get rid of a power, which we do in this case, all we do is we apply log to the base of that power equals log 3, 13. So just to give you an example or a reason as to why this works, if you remember from the power law, right, this one here, we can bring the power to the front. So now we have x. I'll only do this once, okay, so don't worry, I won't do this every single time, because this is meant to be fairly quick. Now, what did I say? Log to the base of a number, of the same number, is always 1. So how many times does 3 multiply by itself to get 3? It's 1. So it's just going to be x is equal to log the base 3 of 13. So you can jump to that step straight away. You don't need to do the intermediate ones because it is a rule. But now you just need to use a calculator. 3 gives me 2.33 to 3 significant figures. Not too bad, hopefully. So again, these will gradually get more tricky. So again, we have 2 to the power of x equals 32. So we want to take the log base 2 of both sides. Because again, we always choose the base of the power to get rid of the power. 2 to the power of x equals 32. And just like in the previous question, that's going to give me x equals, my apologies, I forgot to do the log. Let's quickly do that. log 2. And again, you can use a calculator, but hopefully you should know this one. It's 5. Again, so these are just quick 2-mark questions, quick rapid fire, but they do come up quite a bit in exams. Now this is where things get a bit more interesting, slightly more interesting. We need to solve an equation. Okay, so what we need to remember here is that we have 2 separate logs. Now, some people mess this up quite a bit. So you can't just subtract these straight away because there's a 2 in front. So just so you're aware, you cannot do that's not the correct thing, because this 2, when we're talking about logarithms, represents a power. Okay? So we need to keep that in mind. So we need to use our rules in reverse now. So this will become log 2 x squared. Again, remember the power rule from the beginning. It's just in reverse. Minus log 2 5, and that still equals 1. So now we can use the subtraction rule, which says that if you subtract 2 logarithms, all you do is you divide them. Okay, now how do we get rid of logarithms? Well, in this previous part, we applied a logarithm to get rid of a power. So, if you want to get rid of a logarithm, you need to apply a power. So what I like to call this is raising to the base, okay? Now, I'm going to do it fully once, okay? So all I'm going to do is write 2, and then this is going to be to the power of log to the base 2 x squared of 5, okay? Now I'm only going to do this once, because after this you should know, and again you do that to both sides, you raise everything to the power of 2. Well, the base 2, you raise everything to its own power, okay? Now I'm only going to do this once. If you remember from our rules up here, b to the power of log to the base b just gets rid of the log and the power, okay? So in this case we have 2 to the power of a base 2, so if you like you can cancel that through and you're just left with x squared over 5 equals 2 to the power of 1, which is 2, okay? So I'll only do that once, but in general, if you just raise something to its own power, so a logarithm to its own base, it gets rid of the logarithm, okay? So, now it's just a simple case of x squared equals 10, x just equals plus or minus the square root of 10, okay? Which it doesn't say to give it any kind of decimal place or anything. But that should be it. Cool. So again, solve the equation. Keep in mind, you can't do this unless you combine the logarithms, okay? So we're adding them, which means we will times what's inside. So we have log to the base 3, x times 4 gives me 4x equals 2. And again, because we want to get rid of a log to the base 3, we're raising everything to the power of 3. I know the way I'm saying that doesn't sound right. I'm not cubing everything. I'm making 3 the base of everything and putting that to the power. So on the left-hand side, that's just going to get rid of the log. And on the right-hand side, that's just going to be 3 squared. Okay? So then 4x equals 9. X equals 9 over 4. That's it. So again, these are 4-mark questions. Really, really short. Really, really short. Okay. They shouldn't provide too much hassle. But let's keep going. They do get harder and harder and harder. Expressed as a single logarithm to the base a. So again, this shouldn't be too bad. This is like part of question 3. First things first. I can't combine unless I get rid of the power first, and the number in front of the log. So let's bring it in. Cool. Now I just subtract them, so I divide them. So this is log base a. Technically I didn't do it quite accurately. This would be x plus 1 squared, not the whole logarithm squared. But that's okay. Super easy. Again, the questions do get harder as you go along. So for example, simultaneous equations. Okay. This is going to be good fun. Might be a bit tricky, but what we need to do is try and find equations or expressions for both of these so we can solve it. So the problem with simultaneous equations is we either need to sub x into here or sub y into there. Either way is fine. Now, I don't think this is too bad, but some people... So, okay, there are two ways to go about doing this, right? So the first way is if I call this equation 1 and equation 2. With simultaneous equations, there are so many different solutions to this, but x would just equal e to the 2y minus 1, right? Now, what I could do, right, is change x. So I can now sub this in to this. However, what might make my life a bit easier is if I make it look like ln x minus 2. So that's minus 1 from both sides. Minus 2 from both sides even. I can count. X minus 2 equals e to the 2y minus 3. Now if I take the natural log of both sides, right, I will have ln of x minus 2 equals ln e to the 2y minus 3. And that is another way to do things. The other way to do it is to simply raise all of this to the power of e and let that cancel out. Okay? Either way is, again, completely fine. So let's have a think about what we want to do. So, okay. Let's leave it as this for now. Let's take the natural log. So ln x minus 2 equals ln e to the 2y minus 3. Cool. And if you're wondering why I haven't done the cancelling thing, so I haven't cancelled ln and e to the twice, because I'm taking ln of the whole thing. Okay. So now I can sub this into here. So we have ln e to the 2y minus 3 equals 2y minus 1. Okay. So we can do a few things to cancel this out. I could raise everything to the power of e, which will get rid of log to the base e. So we have e to the 2y minus 3 equals e to the 2y minus 1. Now, this is where things might get tricky. Okay? E to the 2y minus 1, if you remember your laws of powers, is the same as doing e to the 2y multiplied by e to the minus 1, right? Because then you add the powers together. Okay? Now, if I actually write out what e to the minus 1 is, it's 1 over e. So this is equal to e to the 2y multiplied by 1 over e. So in other words, it's e to the 2y over e. So let's write that out. E to the 2y minus 3 equals e to the 2y over e. Okay. So that's meant to be a y. So what we can do now is move all of the y's to one side and all the numbers to the other side. All the e's to the one side. So if we move this to the other side, this to the other side, we get e to the 2y minus e to the 2y over e equals 3. Factorise out an e to the 2y. Move that over to the other side or divide it, so e to the 2y. And all we need to do now is take the log of both sides. So 2y equals... And yes, this looks absolutely heinous. That's totally fine. Remember, e is just a number, so that should be totally fine. Let's get our calculator out. So 0.5. ln is this button here. 3 over, so 1 minus alpha e. Whoops, that's not even right. That's 1 over alpha e. And yeah, 0.7786. So does it tell me how many decimal places? To 2 decimal places, so that'd be 0.78. Okay, so again, this is a 7 marker, so we can't really expect the answers to be nice at all. So what I'm going to do is, just in the interest of room, is we need to sub this in to find what x is. The easiest x equation I can find is equation 1, right? X equals 2y minus 1. So x equals e to the 2 times what we just found out, 0.78 minus 1. But I'm going to use the answer button, of course, to make sure my answer is perfectly accurate. So what we're going to do is e to the power is shift ln here, to answer button, and then minus 1, which gives me an answer of 3.75 to 2 decimal places. And that's a 7 mark question. Honestly, it's not that bad. If you think about it, it's ugly, sure, but it doesn't mean it's difficult. Okay, but yeah, I think it's okay. 7 marks is a lot of marks. It's probably one of the highest marked questions that you'll get. Okay, something that's slightly easier to digest. We have ln 2x plus 5 equals 1. We have to solve for x. Okay, so we have ln 2x plus 5 is 1. And again, the opposite of ln is raising everything to the power of e. Okay, so that will get rid of the ln, equals e to the power of 1. Okay, so then all we need to do is rearrange this. So x is equal to e to the 1 minus 5 over 2. And that will give us an answer because it's an actual number. Now, you are allowed to leave your answers in terms of e, because e is an irrational number. It goes on for an incredibly long time. So this would give you full marks. But if you want to be super accurate, I guess. Not accurate, but if you want to write it out, do that. I like to write it in both ways, and that way the examiner knows I know what I'm talking about. And they can give me marks for either one, either way. Totally fine. So, next question. So this is where things are going to get a bit tricky, because we have some algebra and we have some substitutions and things like that. So, hopefully this is okay so far. So we have y equals log to the base 2 of x. So if we have a look at the first one, which is log to x squared, the most common thing I see is y squared, which is not right. Look what it is. The power law means that this would become 2 log to the base 2 of x. So if y is equal to log base 2 of x, then that is equal to 2y. Okay? Just keep that in mind. Okay, now let's go for the next one, part B. This one, some of the things I see are just blank looks of confusion. Now the thing is, we can't just write y in terms of this. In fact, we can't really change that into this in any easy way. So let's have a think. How can we make log 2x out of this? Well, if we use the addition rule, right, this is 2 times x. So this is the same as writing log to the base 2 of 2 plus log to the base 2 of x. Now log to the base 2 of 2 is 1, and log to the base 2 of x is y. Done. This next one is actually not on a lot of your specs anymore. It's a slightly older question. So log to the base 8 of x. This is called a change of base. So we need to do change base. And what that means is, I'll show you. Log to the base 8 of x is equal to log to the base 2 of x, because 2 is the base we want, over log to the base 2 of that. So essentially, if you want to write this out, log to the base b of a is equal to log to the base c of a, right? So c is the new base, over log to the base of the new base of the old base. Okay? And of course that would make y log to the base 2 of 8 is obviously 3, because 2 cubed is 8. Okay? And that will be 2 marks a pop. 6 marks in total. Not bad at all. So again, the change of base hardly ever comes up, but it's a good thing to remember if it's on your spec. So, question 9. Here we go. In exact form means that we're probably going to have ln or e in our answer. In this case, it's going to be ln, but in other cases, it could have been e. So, this is going to be kind of interesting. So, what do we want to do? 2ey. Let's move everything to one side first of all. Now this kind of reminds me of a quadratic equation. The only problem is this isn't squared and this isn't to a normal power. So what we're going to do is we're going to multiply through by e to the y. So that gives me 2 e to the 2y, right? And that's going to give me 15, because e to the minus y times e to the y, that will give me e to the 0, which is 1. Minus 11 e to the y. So if I write this out like here, that looks like a quadratic. One way I could make it look more like a quadratic is say x is equal to e to the y. In that case, I'll have 2 x squared minus 11x plus 15 equals 0. And now what you're able to do is factorize, completing the square quadratic formula, whatever way you want to do it. But if we factorize this, it's just going to be 2e to the y, and in the other bracket it'll have to be e to the y. Or again, if you want to look at that over here, it's going to be 2x and x, and then we're going to have minus 5 and minus 3, 0. So if I flip over to here, it's going to be minus 5 and minus 3 equals 0. Really doesn't matter each way. So either we have 2e to the y minus 5 equals 0, or e to the y minus 3 equals 0. And we solve it in the exact same way. So we have e to the y equals 5 over 2. So take the natural log of both sides, we get ln 5 over 2. Again, it can't be less than 1, just bear that in mind. Or y equals, so I should say e to the y equals 3 ln 3. Okay, so again, if one of them was negative, we'd be able to discount that immediately, which can be a useful thing to do. Okay. Here we go. So this is part of the exponentials and logarithms chapter. Is they really have a big focus on what I like to call synoptic maths. So this is where maths is applied to real world situations. Bearing in mind there is one question you may not be able to do yet, but I'm going to go through it, even though we haven't gone through it in one of these YouTube videos, because this is going to involve differentiation. Okay, and that's because it says rate. Anytime we have a rate, it's going to be differentiation. Okay, but I'll go through it, I'll talk through it, but this isn't a differentiation video. Okay, so population of speed, and this, by the way, this kind of question comes up every single year, right? And the structure is identical. They will always ask you initial number, then they'll ask you a rate, then they'll ask you to work out how long it takes. This question and this style comes up every single year, okay? Because it's the perfect synoptic question. It teaches you about exponentials, it teaches you about differentiation, it teaches you about exponentials again, okay? So this question is basically guaranteed to come up, and it's the same exact formula, okay? Initial, rate of increase, how long. That is it. Always, 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 always. Part D is sometimes like a limitation. So some kind of limitation, okay? In this question it doesn't have it, but in some questions it will have it, but everything else is the same. Species of a population of a species of a plant modeled using the formula P equals 50 E 0.1 T, where T is the number of weeks. Okay, cool. But I've done the number of plants when the population was first recorded. If it's first recorded, it means T is equal to 0. No weeks have passed. So P is equal to 50 E. 0.1 times 0 is 0, so that's going to be 50. Okay? Now, here's the trick to this question. Whenever it says initial, it's always just going to be the number in front of E. Okay? So this 1 mark question is just the number in front of E. Part B says find the rate of increase 10 weeks after the population was first recorded. The first thing we need to do is find the rate of increase. So if P equals 50 E to the 0.1 T, then we need to find dP by dt. So to differentiate, so if we have y equals e to the, what should we call it, ax, then dy by dx is going to be a e to the ax. So all you do is you bring the thing forward. So here I'm bringing 0.1 forward, so we have 50, 0.1, times by the exact same thing again. Okay? So 50 times 0.1 gives me 5 e to the 0.1 t. Okay, differentiating exponentials is super easy. Now it says 10 weeks after the population was first recorded. So when t equals 10, dp by dt equals 5 e to the 0.1 times 10. So in other words, it's 5 e to the 1, which is going to be, I actually have to use a calculator for that because it's going to be 5 times e, so 5. 13.59. So does it say to 3SF? Nope, but we should probably give it to 3SF just because it's a long number. That's it, 2 marks. Okay, now part C is where things get a bit funky. So, we're looking for, find out how many weeks it takes for the number of plants to exceed 300. So we're subbing in P equals 300. And again, this structure is always the same. Initial amount, T equals 0. B, you're going to differentiate. C, you're going to sub in something for the P or whatever it is. It's always the same. Okay? So you have 300 equals 50 e to the 0.1 t. Okay, this is 4 marks, it's not too bad. We want to rearrange for t, so let's divide both sides by 50. Remember, only take logarithms if you have one number in the expression, right? If I take logarithms of this at the beginning, it's going to mess everything up. Only have one number, one exponential. That's when you take logarithms. Okay. Likewise, if you want to take the exponential of both sides, right? You want one number, one exponential, one logarithm. That's it. So 300 divided by 50 is 6 equals e to 0.1 t. Now I have one number and one exponential, so I'm going to apply the natural logarithm to both sides. So ln 6 equals 0.1 t. So t is equal to times both sides by 10 or whatever you want to do. What's that? You can divide both sides by 0.1 as well if you want. So it's going to be 10 natural log of 6. That gives me an answer of 17.9 blah 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 blah. Right, now if we look at the question, it says find out how many weeks it takes for it to exceed. So it can't take 17.9 weeks, right? It's how many whole number weeks. So it takes, always round up, 18 weeks. And what I mean by always round up is if this number was 17.00001 weeks, you still round to 18. Because it's taking 17 weeks and a bit. So how many total weeks does it take? It takes the next number up. There you go. 7 marks. Not too tricky, hopefully. Not too bad. So for those of you doing A-level physics, you're going to feel right at home here. For those of you that aren't, still the same stuff. The decay of a radioactive substance is modelled using the formula N equals 1000 e to the minus kt. Right, and look at this, right? Where N is the number of atoms, cool. Write down the number of atoms when it started to decay. Well, again, we're subbing in T equals 0. So N equals just the number in front of E. Okay, that was hard. Given that it takes 14.4 years for half of the substance to decay, find the value of K to 3SF. So in other words, when T is equal to 14.4, and again remember, it's always a substitution, right? Now, I may have led you to believe that it's always the same, but keep in mind there's always 10% unseen marks. So this is where part B was the unseen mark, or unseen question of the paper, okay? It's always substitution, but they've changed it now, slightly, okay? But normally it's always the kind of same thing, right? N is half, so 500. So let's sub that in. 500 equals 1000 e to the minus 14.4 k. Okay, shouldn't be too bad. Divide both sides by 1000, I get a half equals e to the minus 14.4 k. So again, remember, we want one number, one exponential. Now we take the natural log of both sides. ln of a half equals minus 14.4 k. If you're worried about getting a negative, right, just so you know, you can't log less than 0. But if the number is between 0 and 1, log of n is always less than 0, it's negative. Now think about why. To get ln of 1 over 2, I need to take the reciprocal, so I need to have a negative power. So if you have log of a number that's less than 1, but bigger than 0, it's okay for this to be negative, okay? So I know the reason why I'm going through this, right, is obviously when you put it in a calculator, you're going to realise that it's completely fine. The problem is that some students panic when they see they've got a negative. They're like, oh, my answer's going to be negative. That's not right. It's right. It's fine. So just make sure that you're being super aware of that. Okay? I'm going to put 0.5 instead of 1 over 2 because I'm lazy. And 14.4. And look, it's a positive number. 3SF, that would be 0.0481. Remember, we only start counting from the first non-zero number. And then lastly, part C, I remember it being fairly easy. Calculate the number of atoms left when T equals 30. Easy. So N equals 1000 E. Now, we know what K is, right? K is 0.0481. And T, in this case, is T equals 30. So all we're doing is subbing numbers into a calculator for a mark, right? A-level maths. So let's click cool. So we have 1000, and then we have shift E to the minus 0.0481, open bracket 30, close bracket, 236, and well, hang on, actually, wait. Okay. So some students actually would leave this as 236.2. How many atoms are left? Can you have 0.2 of an atom? Nope. So it's 236 atoms. Okay? It's an easy question, but some students just sub it in, they round it to 2 decimal places or something. Some students will be lucky and will round to 3 significant figures and just happen to get the answer right. But obviously you don't want to rely on luck or happenstance. Be super careful with that. Okay. So again, these are the kinds of questions you can expect. And again, we have another kind of question. And rate of change, etc., etc. So this is probably one of the hardest style of questions because again, it was unseen. So let's go through it. If you can do this question, you can probably do, I would say you can pretty much do any A-level question. It's all we'll have time for today after this question. But again, when we start going through exam papers, we will encounter far more, and honestly they all are very similar, but there will be some variation in that sense where obviously the equation's different, so it's good practice. Find the rate of change of the temperature in terms of K. Cool. Rate of change means we're doing differentiation. So again, what we're going to do is bring the number in front of T forward, so minus K, and then the rest of it stays the same. Now, constants, when you take the rate of change, go away. So all you have here is minus 75k e to minus kt. Now, if we think about this, right, where the temperature, this is the temperature after turning the kettle off. We're saying how quickly does the temperature change? It should make sense it's negative, right? Because the temperature should be decreasing over time. That's 2 marks. You know, that's not really bad. Part B. After 5 minutes, the temperature of the water is 70 degrees. So what we're saying is 70 degrees equals 75 e to the minus, how many minutes was it, sorry? 5 k plus 22. Also, this plus 22 should also make sense if you think about it. That's room temperature, right? The temperature of the water should never go below room temperature. Right? So these maths equations, like, they do put some thought into it. They don't pull numbers out of thin air. Okay? So, minus 22 to both sides. That gives me 48 equals 75 e to the minus 5k. Divide both sides by 75. Was e to the minus 5k. Ooh. Take the natural log of both sides. So we have ln. And again, the reason why it's the natural log is because my power is e. Okay? So we're taking log to the base e, which is ln. And again, there's a negative, but that's a good thing, because this fraction is less than 1. So, we have ln 48 over 75 over minus 5 will give me the answer. It's going to be a bit slightly painful to type into the calculator. So we have ln, and then we have a fraction, 48 over 75, and that's over minus 5. We get 0.0893. It doesn't say how many sig fig, but it's normally 3 is good. So 0.0893. If you're wondering why these numbers are so ugly, it's because, again, these equations, they don't come out of thin air. K and these constants tend to be very small or very weird numbers, right? The universe doesn't really play by our rules in that sense, in terms of having whole numbers and things like that. We're not normally lucky. But how many minutes it takes to cool to 55 degrees. So, T equals 55. So we have 55 equals 75. I'm just doing this based on memory, so I will check it in a second. T. So that's what our equation looks like. Good. Subtract 22, we get 33. T. And again, we're doing basically the same thing we just did. 33 over 75 equals E to minus 0.0893 T. Natural log both sides. T. And then lastly, divide both sides. And because I'm an absolute genius, I've actually left this as is. So what we can do is actually edit edit the equation instead of writing the whole damn thing again. 9.193 blah 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 blah, right? And remember what I said. How many minutes does it take? Well, it can't take 0.19 of a minute, so it takes 10 minutes. Okay, so I know that logarithms and exponentials are slightly obscure things, right? They're very difficult to imagine. So I thought it might be good to go through some real-life applications for them. So again, if you're doing physics, exponentials and logarithms, anything to do with physics, so engineering, etc. Even if you're going to become a doctor, for example, you're going to have exponential decay of things like medicine that stays in the blood, for example, and things like that. You also have exponentials when you're talking about like the stock market, for example, right? Wealth in the world tends to increase exponentially. So those are the kinds of things you can think about. Compound interest. Literally anything with powers has logarithms as well. So they're very useful things to talk about indeed. But that is a pretty good summary of all the different types of questions you can be asked. And that should be enough for today. So I hope you enjoyed.